Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm over at Semi with Tom Salmon, who's going to talk today about what's changing in smart manufacturing. Tom, smart manufacturing is not a new idea. As a matter of fact, we've talked about it before. What's changed?
So smart manufacturing, you're right, Ed. It's been around for a while. Semi's been working on our smart manufacturing standards for quite some time, moving from SEX to GEM to the EDA standards that we have today. I think what's different is that companies are looking at investing more and really ramping up their smart manufacturing or Industry 4.0 capabilities to get more value out of the overall productivity.
What was the trigger here? Because we've been hearing about it for a while, but it seems as we start getting down into the most advanced nodes in semiconductor manufacturing that there's suddenly more interest in this.
Yeah, so I think there's a couple of triggers really. One is the intense level of the sensorization. So putting the sensors, MEMS sensors into the equipment, into the product line. But at the same time, along with the shift to more of a consumer market focused, for at least for microelectronics and semiconductors, is this complex supply chain, this pressure on the time to market, that's really driving the need to kind of ramp up our productivity capabilities.
Why don't you draw this out for us?
All right.
So now that you're starting to get data back on what's happening in smart manufacturing, what does it actually show?
So a recent study at Capgemini actually found that smart factories, so companies that are using smart manufacturing akin to Industry 4.0, overall have the ability to add between 500 billion and 1.5 trillion dollars to the global economy over 5 years. So there's the value. That's the plus. That's the ROI back to those companies as well. But at the same time, the efficiency. So for smart factories over the period from 2017 to 22, they are predicting 7x the levels of efficiency and productivity that they had in the period since 1990. So it's a pretty big increase in the productivity and the overall value.
What's the metric here, though? Is it throughput in a fab? Is it yield? What are we looking at?
So we're focused, at least on Semi and the programs and the communities that we have so far. We're looking at least first on OEE, on overall equipment efficiency. We'll look at other factors further on down the line in terms of whether that's energy savings, clean energy, so environmental health and safety, reduction of waste, and other factors. But this first generation, in order to realize this efficiency, we want to focus on the OEE.
Is the goal here to speed up throughput in the fab? Is it to decrease the cost of what it takes to develop a chip? All of the above?
Yeah, I think all of the above. There is a feedback cycle from what we can learn that goes back into developing the chips. But I think in terms of increasing the throughput, increasing the quality, reduction in labor costs, all of these come into play in the work that we're doing.
This is a very complex supply chain, though. What sort of problems do you run into?
Yeah, so when we look at the opportunity here, and then the challenge is where only 14% of the companies are actually satisfied with their smart manufacturing efforts, and only 6% of those companies that responded to the Capgemini survey were actually considered digital masters. The main reasons behind that, though, issues that we're running in specific to the microelectronics, are related to not just the complex supply chain that you mentioned, but also we have, to a large extent, in many of the MEMS and sensors and more fabs, we have legacy tools that we need to integrate. We also have quite a bit of IP and security issues that we need to overcome.
So this isn't just the 753 nanometer, it's also some of the 200 millimeter type of processes as well, right?
Exactly. In many cases, while the leading edge nodes, I think will probably get the best bang out of the buck for advanced compute capabilities, so your machine learning, AI, building in those capabilities into the fabs. Many of the more fabs where we're still using 200 millimeter or even lesser diameter equipment still have a huge opportunity to put in some of the advanced smart manufacturing capabilities like FDC and others.
There's also a need for more data and more depth in the data than what's been there before. And we're starting to see this particularly in medical, automotive, any of the safety critical type of applications as well, right? So that's becoming a much more data driven type of environment where you really do need the latest equipment and latest processes.
Exactly. So most of the recent equipment has those capabilities built in. The equipment manufacturers have been very good at leveraging the semi-standards are in place, so we have an efficient mechanism for building in those new capabilities. The challenge then becomes on how can I integrate some of those new capabilities into the older equipment so that I can get those same efficiencies at a MEMS fab or a sensor fab or a power semiconductor fab as well. But you're absolutely right. The data is critical, not just for sort of the feedback loop for producing chips, but also in terms of the speed, quality, and output. So if you're looking at scheduling, for example, or waste reduction or some of the areas, getting all that data and using all that data. Currently, we probably only use maybe 10% of all the data that we pull off the equipment.
What does this look like long term? What do you see as the upside of this?
So I think the upside for the industry, I mean, if you can look at it, the numbers are kind of jump out at you right here when you're talking in the trillions of dollars or 7x improvements in productivity. But long term, I think also we look at the microelectronics contribution to the general health of the planet and the people that live there as well too. And so we're really looking at long term, how can we improve the productivity of our fabs, improve the workforce that goes into whether that's in data science or other areas, and also at the same time make sure that we're being responsible in terms of our waste reduction and using green processes as much as possible.
What took so long to get this going? This has been talked about. I think Industry 4.0 out of Germany was started back in the early 2000s.
Yeah, so I think again for us, really it had been. I think there was an underlying skepticism, right, within the industries. I think when management looks at the sort of the ROI for some of these capabilities as compared with some of the IP and security risks that are in there, the risk reward profile just wasn't what it needed to be to get it going. I think again with the build-in of the sensors and some of the work that we're doing on the cybersecurity to overcome some of the IP and cybersecurity's potential of using technologies like blockchain to overcome some of those issues, I really think it's given it a jump start. The other thing, I think, to be quite honest, is there just wasn't enough awareness and knowledge about the capabilities of smart manufacturing, and that's what's leading to the benchmark that SEMI is doing. So first ever, as far as we know, it's the first ever done in our industry, in the microelectronics industry. We're releasing the benchmark this week, the survey this week, and that will put a stake in the ground, a benchmark exactly what those, what implementations, what capabilities are out there, and also what the industry readiness is in terms of putting those implementations in place.
Do you foresee this moving to other industries as well besides just semiconductor manufacturing?
Absolutely. So there are several industries that are moving pretty fast ahead of us. I think the automotive industry is gradually building these capabilities in some cases more recently, perhaps even a faster pace than the microelectronics industry. But we see these capabilities moving on, and I think a number of our equipment manufacturers are also looking at the capabilities moving into, say, biopharma or pharmaceuticals in general, and other areas as well too.
Tom Salmon, thanks for a great explanation.
Absolutely, always a pleasure, Ed. Thank you very much.